Hello, my name is Logan Hazer. This is a showcase of my final project. There are some nuances and quirks with it. For example, the very first time you send data over the USART cable, or the USART cable all the way to the atmega, for some reason both the wind speed and the temperature get the same value for that very first time, but then after that it updates correctly. I'm not entirely sure why the very first time it doesn't get the correct value. I think it has something to do with how the Pi serial library works, but I have not been able to fix that. So anyway, continuing on, I'll show you later. I'll show you later what I mean by that. I just want to talk about what pieces are here and what they all do. So I have a battery pack here, which is supposed to be plugged in here to power the motor. However, I couldn't get the battery pack to work with it. I'm not sure if the prongs aren't long enough, but for the purposes of this demonstration, I am powering it with this spider I made. The spider here is just providing power for the DC motor. The actual L293D driver for the motor here is getting power from the USART cable, as is the atmega and the LCD screen. I'm not sure if that's too much power draw on the USART cable, but it works, so that seems to be fine. Here's the atmega, obviously, and the DC motor and the two LEDs. And here is the LCD, of course. Yeah. And if we look at the front of it, hold on a second. That one should be ticking slightly because it should be going 3 miles per hour. Let me reset it real quick just to see what's going on. There we go. So now if you look at it, you can see it's going really slowly. That is it going, sorry, my battery is dying. That's it going 3 miles per hour, because that's the default. And also the reason why the green LED is on is because the default is 85 degrees, which is less than 90 degrees. 90 degrees and above will turn on this red LED here. So yeah, let me show you how this works. Oh yeah, also I just wanted to say, the very first time you boot up the atmega, this thing the LCD doesn't have anything on it, because it's waiting to update until you get actual values there. Because there's no point in updating it every single loop through. The only time you need to update it is when you get a new value from the terminal. Because otherwise the wind speed and temperature haven't changed, so there's no point in getting that value. Alrighty. Updating it. Alright, so let me show you my Python program. For the purposes of this demonstration, I have modified it, so instead of using the web scraping, which you can see is up here, it will use command line arguments. So that way I could very easily cause this thing to turn red and this thing to go back on, increase the wind speed, and show you it here. As I said earlier, the very first time I run it, both of them get the same value for some bizarre reason I do not understand. So I will demonstrate that here. So what you do is you use Python 3, because the modules I'm using require Python 3, and you launch the program. So this should launch it with a wind speed of 10, which should make the DC motor go faster, and a temperature of 92. However, since the very first time you run it, they get the same value, I'm going to change the temperature down to 10 degrees, because 92 will cause the DC motor to go really, really fast, and then it will take forever to update to the actual correct value. So that would, I'll show you that afterwards. Right now, I just want to show you the demo of what it does when it works. So you send 1010, you look here. Just gotta wait for it. 1010. So right now, it has 1010. I sent 210, so of course it's the same. But really, the first time it sends 2 10s, it's actually, here, let me show you, where's the cursor? It's actually 2 of the temperatures, and then after that it'll update with the correct value. So if we kill the program real quick, and then rerun it with, say, a value of 10 and 92, it'll update, And you notice this time it doesn't set the wind speed to 92, so the motor's not acting crazy. And if we look over here, the motor, you see the red light went on? That's because the temperature is 92, which is above or equal to 90. So the way I wrote my the part of the program, the main program that updates the DC motor speed, it goes in reverse for 200 milliseconds to slow it down before it sets the new speed. The problem with that is that for lower speeds, it actually ends up stopping it. So the only way to really tell the speed is to see how fast it rotates in that one pulse. I could probably fix this pretty easily just by making it so it doesn't go in reverse. But the problem I was running into was trying to get the higher wind speeds, like 75 or almost like max speed for the DC motor, trying to get those to slow down in time, slow down enough that like if I send a new value that's less, like if I send 75 and it's going really fast and I send 10 afterwards, it'll take a long time to actually slow down. It might be because of the DC motor just not being good at stopping, but also that I've read online that the L293D driver does not have good braking control for the motors. Although I think it's probably just an issue with the motor itself. So yeah, that's why it's not continuously pulsing right now. That's because of the code I added, which goes in reverse for 200 milliseconds. But as you can tell, it's actually going faster than it was before. Like it's going further and faster. So if we kill the program again, and then we change it, so instead of 10 miles per hour, for example, let's say it's going 50 miles per hour. And let's say we change the temperature down to 3 degrees Fahrenheit. We send it, you see the green LED went on, and if you look down here, it updated down here as well. And if you listen carefully, if you see here, it's actually going faster and farther than it was before. This is a clear indication that the wind speed has indeed increased. It's not as good as it was before I added the reversing in, but it is good enough to tell that the wind speed has dramatically increased, especially relative to the base case of having it 3 miles per hour. And then let me show you what happens if we set it to something like 75, because I think it's important to note it, to acknowledge room for improvement. So if we kill the program again and launch it with a wind speed of, for example, 75, which is half the max. Launch it with 75. It should update. Yep. So if you look now, it's going really fast. It's going so fast that even though I reverse the motor, every update, it's not actually slowing down. So reversing the motor doesn't actually break it like I had hoped. I actually did try using high and high to use the electromagnetic properties of the motor to cause it to stop, but that doesn't work either. So what happens now is if we kill this program and then send something like 10, even though it's trying to send it, it's actually going to take a long time for the motor to slow down and stop because of how fast it's going. It will eventually slow down, but it takes a long time, like a minute, maybe a minute and a half. Since this video has to be 10 minutes long, I actually cannot demo that. I might include a link to a video demoing that in my file. But yeah, that's what my program does. Oh yeah, here we go. So it stopped, and it's going to start again for a bit, and then it's going to stop again, and then it's going to actually update. I'm not entirely sure why that happens. I think it's drawing too much power. But yeah, that's my project. I hope this explanation was satisfactory, and I hope that you enjoyed it. Oh, the web scraping does actually work. I just didn't demo it for this presentation because it's easier to show specific values. Thank you.